This is a video that demonstrates how to build NXP's MCU OTA software and deploy it on an iMX RT1176 developer's kit. A link to the document that contains the instructions is available in the description below. The first step is to get the software for the secure bootloader, SBL for short. The software is available on GitHub. After that, we need to specify the path to the toolchain we will be using to compile the software. This is done in the file sblprofile.py. The project will be built using SCON's build system. In a Windows environment, this system is initialized by double-clicking the env.bat file. Enter SCONs in the command prompt to build the software. When successfully built, there will be an sbl.bin file in the build directory. We will use the GUI flash tool within MCU Expressor to flash sbl.bin to the target. See the document for instructions on how to set up MCU Expressor. Click on the GUI flash tool icon. Here you can see that we have an MCU Link Pro attached to the target. Click on File System and browse to sbl.bin. Don't forget to change the base address. When the file has been programmed, reset the board. Here you can see the output from the bootloader. As you can see, it doesn't find any bootable image. The second part of the software is the secure firmware, SFW for short. This part contains the logic needed to check for and download updates from a cloud service, such as Amazon Web Services, AWS for short. Your application logic should also be in SFW. In this demo, the application is a simple Hello World application. The first step is to get the SFW software. It is available on GitHub. We are going to work with version 1.1.0 in this case. We need to specify the path to the toolchain we will be using to compile the software. This is done in the file sfwprofile.py. Since the iMX RT1176 developer's kit uses a different Ethernet PHY compared to NXP CVK, the source code needs to be patched. Download a patch. Apply the patch using git apply. Here you can see the files that have been modified by the patch. You need to set up AWS IoT services as described in the documentation. We are not showing this part in the video. One of the steps to set up AWS IoT is to create certificates and keys. As you can see here, they have now been included in the code by updating two header files. The project will be built using SCON's build system. In a Windows environment, this system is initialized by double-clicking the env.bat file. Before building, we need to configure the project. We enable AWS as the OTA service. We set the MQTT broker DNS name and the IoT thing name. We also need to set which embed TLS config file to use. Save the changes and then build a project using scons. When successfully built, there will be an sfw.bin file in the build directory. This file needs to be copied to different locations, but before doing so, we need to know the version of the application. Here you can see that the version is 0.9.2. The file must be copied since it's going to be signed before deployed to the target. Rename the file so that it contains the version number before signing it. Here we sign the file. If you have a terminal application connected to the target, then first disconnect this, since we are going to use MCU boot utility to program the board. This utility is using the COM port to interact with SBL. Make sure UART is selected as interface and then set COM port and baud rate. Click Connect. Also make sure you have the correct target setup. In this case, we use an iMX RT1176. Go to the boot device memory tab and change the start/offset field. We will program SFW at the 1 MB offset from the start of the flash. Browse to the signed SFW file and select it, then click the Write button. Now you can connect the terminal application again and reset the board. When the bootloader starts up, it finds an image in the primary slot and boots that image. You can see that Hello World is printed in the console. The application will also try to connect to AWS IoT. We will also show what happens during an OTA update. Please note that building and uploading a new file to AWS IoT is out of scope for this video. Read the documentation for instructions. The application detected that the new image is available and will begin to download it. The video playback speed has been increased. Once the new image has been downloaded, it will be validated. If correct, it will be activated and the device will be reset. Now the board has been restarted after the reset. Here we can see that the new version of the image is used. That's it for this video. If you have any questions, don't hesitate to contact us. Thank you for watching.